You're welcome back to this channel. So in today's class, we want to study mathematical induction. I have seen that mathematical induction is like a big problem to students. So in order not to have issue with it, that is why I want to treat it today. So if you want to study mathematical induction, you have to understand what natural numbers are. Natural numbers are the counting numbers. That is 1, 2, 3, 4, 5, 6, and so on. And what is mathematical induction? Mathematical induction is a process or technique or method of proving a theorem, a statement, or a formula that are asserted about the natural numbers. For example, we want to show that sum of natural numbers is equal to n into bracket n plus 1, everything divided by 2. In mathematical induction, there are two steps that are very important that we have to follow. The first one is basis step. Basis step. Basis step. This basis step show that n is equal to 1 is true for this equation. N is equal to 1 is true. So, and that is whenever we see n, we are going to put 1. So be equal to 1 into brackets 1 plus 1 divided by 2. So 1 is equal to 1 multiplied by 2 divided by 2. So 1 is equal to 2 divided by 2. 1 is equal to 1. So we can see that when n is equal to 1, this statement is correct. When n is equal to 1 is true, that means its successor, which is 2, must also be true. So let's check. So n is equal to 2. When n is equal to 2, let's see what happens. So that means we have the first one plus when n is equal to 2. So it will now be equal to, wherever we see n here, we are going to put 2 into bracket 2 plus 1 divided by 2. So 2 cancel 2 here, 2 cancel 2 here. So 1 plus 2 is equal to 3. Can you see? So it means that when n is equal to 2 is also true. N is equal to 2 is true. Followed by the next number, which is the successor of 2, and that is 3. So when n is equal to 3 will be 1 plus 2 plus 3. Since we are dealing with sum of natural numbers, so this is when n is equal to 1 plus when n is equal to 2 plus when n is equal to 3. So the general formula now is, so n into bracket n plus 1 divided by 2. So wherever we see n here, we are going to put 3 into bracket 3 plus 1, everything divided by 2. So 1 plus 2 plus 3 is equal to 3 into bracket 4 divided by 2. 2 here, 1, 2 here, 2. So 1 plus 2 plus 3 is equal to 6. So it means that when n is equal to 3, the statement is true. So you go on like that. Now, if I do not want to go on for all the steps, since I cannot solve for the sum of all the natural numbers, it's like I'm climbing step. So I've proved that the first step is true. The second step, I climb it, I see that it is true. The third step, I see it is true. Okay, what if I jump to any number of steps? Will it also be true? So wherever I step on, I want to name that number to be equal to k, because I do not know the number, so I want to assume that number is k. So we can now say that this is induction step now. Assume that n is equal to k is true for this statement. So to do that, it means that I will now say 1 plus 2 plus 2. You know, I've climbed the step for all this one now. So plus dot dot dots. You know, I jumped plus now k. Wherever I see n now, I'll put k. The general formula still remains, so I'll just substitute the value of k there. So k is equal to k plus 1 divided by 2. So if this assumption is true, it means that its successor will also be true, and its successor will be what? K plus 1. Because if you see here, the first term and the first term here is 1, its successor is this 1 plus 1 gives you this. The next number, which is successor of 2, is 2 plus 1, which is 3. So it means that after I have jumped, its successor also will be what? K plus 1. So we want to prove or show that n is equal to k plus 1 is true, since n is equal to k is true. Now, what we're going to do now is that we have to write all the number as we had them before. So we have 1 plus 2 plus 3 plus ... plus k. Now, plus the successor now, which is k plus 1 is equal to, I do not need to change this formula. So I'll just substitute the value of wherever I see n, I'll put k plus 1 there. So I have k plus 1 into brackets k plus 1 plus 1, everything divided by 2. Now, let me name this one equation 1. So from here now, I want to prove that this left hand side is equal to the right hand side. So recall or substitute. So name this one equation 2. Substitute equation 1 into equation 2. So that is here. Wherever I see 1 plus 2 plus 3 plus ... plus k, I have to put k into brackets k plus 1 divided by 2 into it. So I have k into brackets k plus 1 divided by 2, then plus the k plus 1 that I added to it. So I want to show that this expression is equal to the expression in the right hand side of equation 2. So find the LCM. If I find the LCM, this is 2. So I have k into brackets k plus 1, then plus 2 into brackets k plus 1, which is equal to, I can factorize k plus 1 out. So I have k plus 1 into brackets k plus 2. Everything is equal over 2. So here k plus 1 into another bracket k plus 2 is equal to over 2 is equal to, what do I have here? K plus 1 into bracket k plus 2 divided by 2. So you can see that the left hand side is equal to the right hand side. You show that whenever n is equal to k is true, then its successor, which is k plus 1, will also be true. So that is how to prove for mathematical induction. So let's solve another example for you to understand it better. Example 2. Prove that the sum of n consecutive cubes is equal to the square of the sum of the first n numbers. That is 1 cube plus 3 cube up to n cube. The general formula for it is equal to n squared into brackets n plus 1 squared, everything divided by 4. Now, the basic step, since we are dealing with natural numbers, so all that n is equal to 1 is true. So if this is true, it means its successor will be true. So that is, whenever we see n, we are going to put 1 there. So 1 cubed is equal to 1 squared into bracket 1 plus 1 squared, everything divided by 4. So this is 1 is equal to 1, then 1 plus 1 is 2, 2 squared is 4. So multiply by 4 divided by 4. So 4 here, 1, 4 here, 1. 1 multiplied by 1 is 1. So 1 is equal to 1. Since the left hand side is equal to the left hand side, that means n is equal to 1 is true. So its successor, so you write the first term plus its successor. Its successor is 2. So 2 cubed. So we want to show that the general formula will give us 2 cubed is 8. So 8 plus 1 is 9. Whatever we want to get here must be equal to 9. So let's check. So wherever we see n in this expression, we're going to put 2 now. So 2 squared. 2 squared into bracket 2 plus 1 squared divided by 4 is equal to 4 into bracket 2 plus 1 is 3. 3 squared, that is 9, divided by 4. So 4 here, 1, 4 here, 1. So 1 cubed plus 2 cubed is equal to 9. So it means this one is also correct. When n is equal to 2 is true for this equation or expression or theorem. Now its successor is 3 cubed. So 1 cubed plus 2 cubed plus 3 cubed. So we want to prove. So wherever we see n here, we're going to put 3. So 3 squared into bracket 3 plus 1, everything squared divided by 4 is equal to 9 into bracket 3 plus 1, 4. 4 squared is 16 divided by 4. 4 here, 1, 4 here, 4. So 9 multiplied by 4 is 36. So let's check this one. This one is 1 cubed, that is 1, plus 8, then plus 27. So, and that is also true. So it means that when n is equal to 3, the statement is true. N statement is true. So I do not want to name the number. Go on. So I have to jump now. Wherever I step on, I want to name it to be equal to k. So then I want to assume that that place that I am is also true. So assume that n is equal to k is true. So then I have to write all the terms. So plus this plus 3 cubed. Then you know I jumped. So this is where I am now. So I'll now say that this one will now be equal to k cubed. That is here. It means that wherever I see n, I put k. So it will now be equal to, the general formula will be k squared into bracket k plus 1 squared, everything divided by 4. So I name this one equation 1. Now, since where I am, I assume it to be true, that means its successor must also be true. And its successor is k plus 1. So, prove or show that n is equal to k plus 1 is true, since my assumption is true. So, then I have to write this expression down. 1 cubed plus 2 cubed plus 3 cubed plus ... plus k cubed. You know, its successor is what I want to add now. So now be equal to k plus 1 cubed is equal to, it means that for the general expression, which is n squared into bracket n plus 1 squared divided by 4, anywhere I see n there, I have to put k plus 1 squared into bracket k plus 1, then plus 1 squared divided by 4. which is the same thing as k plus 1 squared to bracket k plus 2 squared divided by 4. So I want to show that the left hand side here, so let me name this one equation 2. So we want to show that the left hand side is the same thing as the right hand side. So let's check. So here from equation 1, we can see that 1 cube plus 2 cube plus 3 cube plus dot 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 plus k cube is equal to k squared into bracket k plus 1 squared divided by 4. So I have to substitute equation 1 into equation 2. So now it means that wherever I see this expression, I have to put k squared into bracket k plus 1 squared everything divided by 4. So k squared into bracket k plus 1 squared divided by 4, then plus k plus 1 cubed divided by 1. So the left hand side now, we are dealing with the left hand side now. So let's find the LCM. So the LCM will now be equal to, find the LCM is 4. So we have k squared into brackets k plus 1 squared, then plus 4 to brackets k plus 1 cubed. Now, this will give me, here now, we can factorize k plus 1 squared out. So I have k plus 1 squared into brackets k squared, then plus 4 into brackets k plus 1 divided by 4. So k plus 1 squared to brackets k squared plus 4k then plus 4 divided by 4, and this is k plus 1 squared. You could remember this. We have a plus b squared. This one will give me a squared plus 2ab plus b squared. So this one is the same thing as 2 squared. So here is the same thing as 2 into brackets 2k. So that means this one, this expression is the same thing as k plus 2 squared divided by 4. So if you like, you can just go on and use your quadratic equation. We can quickly do that one as well. So k squared plus 4k plus 4. So multiply the coefficients of the variable with the highest degree. So we have plus 4. So look for two factors of 4. If you add together, you are going to get plus 4. So this is k squared plus 2k plus 2k plus 4. So I have k into brackets k plus 2 into bracket plus 2, then k plus 2. So I have k plus 2 into bracket k plus 2. So that is that. It's the same thing as k plus 2 squared. So I just show you. So you can see that my left hand side is the same thing as my right hand side. That means whenever n is equal to k is true, its successor, which is n is equal to k plus 1, is also true. Proved. So till I see you in the next class, thank you for joining me. Bye bye.